let's talk about the relationship between arrays and pointers so everything becomes crystal clear for you. I'm going to declare an array of integers and initialize it with 3 numbers. Now over here, numbers is technically a pointer to the first element in this array. So you know that if we print numbers, we see a hexadecimal number, which is the address of a memory location. This is the address of the first element in this array. So if we use the indirectional operator here, we should see the value 10. There you go. Now similarly, we can declare an integer pointer and initialize it with our array. Because the compiler treats this as an integer pointer, so we can initialize this integer pointer with another one. Now once again, if we print pointer, we're going to see the address of the first element in this array. If we use the indirectional operator, we're going to see the value of the first element. And if we use the bracket notation, we can also access other elements in this array. In this case, the second element. Okay? So this is the relationship between arrays and pointers. Now let's define a function that takes an integer array. So print numbers that takes an array of integers. Now, once again, the compiler is going to treat this as an integer pointer. That is why in this function, we cannot pass the numbers array to the size function. We get a compilation error because numbers is an integer pointer, so it only holds a memory address. We cannot pass a memory address to the size function and figure out how many elements are stored at that location. Do we have 5 elements after that? Do we have 10 elements? The size function has no way to know. For the same reason, we cannot use a range-based for loop here. So for int number in numbers, again, we get a compilation error because we cannot loop over a memory address. This is the reason why when using the built-in arrays, we should always pass their size as well. Now, there is one thing I want you to pay attention to here. Because numbers is treated as an integer pointer, that means our array is passed by reference. So any changes we make to this array is going to be visible outside of this function. So let me just remove the size parameter. We don't really need it. If we set numbers of 0 to some value, this change is going to be visible outside of this function. So let's call the print numbers function and pass the numbers array. Now if we print numbers of 0, we see the number 0 on the terminal. So remember, function parameters that are arrays are passed by reference, and this is done for efficiency. So when we pass an array from one function to another, we don't want to copy all the values in that array because we might have thousands or millions of objects in that array. That's why the C++ compiler always passes arrays using a pointer.